Hello everybody, so welcome back for another video, and in the next few videos we're going to start deep diving into Hive. Now, right now what we're going to be looking at is the brain of Hive. That brain is the metasystem. But what is the metasystem and how to work with it is what we're going to be looking at. That's before we get into the code. Now, the metasystem itself is not directly associated to Hive. Hive only utilizes it. The metasystem that we have in ZooTools is used in a number of our tools to track information in the scene, like shaders, to our lighting tools, to our new joint-oriented tools, and also obviously Hive. It's just the difference between those tools and Hive is Hive utilizes it quite extensively in terms of there's potentially dozens of these nodes or hundreds of these nodes, depending on how big your rig is. Now, this is not your controls or your guides, but it goes into more fundamental practices of being a developer. We've always needed a way to track information about an artist's scene. That's a fundamental practice that we do as TDs, as riggers. We need to be able to understand what is inside of our scene. So what does this actually look like, and how big does it get? Now, the metasystem doesn't look massive ultimately compared to an actual size of a rig, but it gets kind of juicy. So let's have a look at this from a node graph level. On this selected node is the meta node. The meta node, if we open this guy up, has a bunch of attributes. There's some very common behavior with these attributes. Quite often, they're message attributes, or basically usually highlighted in blue. But we also have things like whether that node is related to Hive, whether it's a Hive root, because we need to determine if it's a Hive root of an actual rig. It also has things like the control display layer and so on. But there's no connections into this section here yet. We do have connections to the meta, children, and the parents, but there's no connection here. And that's only because we haven't actually graphed it. And I'm not going to do that right now because it gets a little bit messy. Let's have a look at the rest. If we keep going down into the component layer, we have the geo layer and the deform layer. Now, if you've watched the other videos, you understand the basic concepts behind layers, their organization layers. And this also applies to the metasystem. We have specific nodes related to the different layers, and this applies to the API as well. Now, if we keep following along from the component layer, you'll start to see we have the God node. That's our component. And if we keep going along, you'll start to crack open the guts of it into the rig layer, the deform layer, the input layer. There's also an output layer as well. And there's a guide layer as well. And then you got the spine. The spine is a child of the guard node. So when you set the parent in Maya, what you're doing is also setting the metadata data to say, hey, the spine is a child of the guard node. We'll get into some of the attributes in a moment. But if I start to open this up a little bit by zooming out bit by bit, you'll start to see things get a little bit interesting. Now, this is not the entire rig. This is just the metadata. This is not your animation controls, your guides. This is just your settings, your attributes, your layers in your rig. So, for example, you've got the input guides offset settings, which I haven't talked about at all. You have things like the control panel settings, which I have yet to go through. But quite often, you'll see most of the nodes are related to layers. Each layer is related to a particular component, and it's a child of the component itself. So if we follow this particular connection, you'll get into the component. If you follow that component along, you'll get to the parent component, and you keep going along, you get that parent component. You'll start to see a common trend that everything is essentially a tree of sorts. But that's semi-true. A tree is typically a parent-child relationship where a node can only have one parent. Now in Hive, that's entirely true, it's a DAG. But the underlying metasystem doesn't have that restriction. You can have multiple parents and multiple children, it's not a problem. But for Hive, we put that restriction in. But what kind of data do we store, and how is this used? So I think one of the most useful things to look at is the layers. So if I grab one of these rig layers, and I'm just going to go to a different tab, and I'll just graph downstream. Now this is going to get a bit messy. If we have a look at this, you'll start to see a fair bit of messy attributes. Now this gets bigger and bigger. I'm lucky this is on the God node and not the arm or a leg or a spine. And it's kind of also lucky that it's the rig layer and not the guide layer, because the guide layer looks a bit nasty because there's so many connections. But if we have a look at this layer node and we look at start connections, you'll start to see a few things. The settings node. So the settings node in this case is an array. And it has a setting node and a name. If we have a look at this inside the attribute editor, and I'm just going to collapse some of these. You have the zoo setting nodes, which corresponds to this compound that we looked at. And you see that the setting name is the control panel. Then we have a look at the node, and it's actually connected to here. Then it starts getting a bit more complex, where you have things like extra nodes. This is how Hive deals with deletion and queries against your entire scene or a rig to determine how many nodes you have or what nodes you have associated to a particular component. You can also get access to the selection sets and so on. There's also a special attribute which I have yet to go through. And that's going to be an interesting one because you'll start to see some of the power behind Hive is the DG graph. That gets into some more complex scenarios, and we'll start to get into that. You'll start to look at how that's actually used in the Bendy system a little bit later. If we have a look at the H controls is basically the Hive controls. So here we're actually tracking all the controls. So we have the God node, the root motion, and so on. If we have a look at these attributes, we have the control node, which is the message attribute. We have the control ID, which is a unique identifier. And if we have a look at that inside the attribute editor, we can start to see there's an array with the control ID here. And this is how Hive gets access to everything in your rig. This is why we don't care about node names. We strictly maintain a unique identifier. That unique identifier is linked to that layer of your component. That ID does not change. We may procedurally generate them depending on the component, for example, twists or IK, but they always have the same structure or format. This allows for your code to work in a more predictable way. Your tools, for example, to always look up the same node no matter what. With this in mind, how do we even build this? Well, it's actually pretty straightforward and has absolutely nothing to do with Hive. And that goes down to the underlying metabase class. So if we do a quick look, before we just jump into the code, one major attribute that we need to look at, and that is the ZooM class. You have a name which corresponds to the meta node instance or the ID. This ID is never changing. Now, we also talked about the root transform previously, where we, in the outliner, in our rigs, if I just turn off DAG objects, you have the deform layer, the component layer, and these are your root transforms, right? Now, we're looking at the God node, so if we crack open the component layer, go down to God, you'll start to see we have that guy. So if I just drag this guy in, oops, that's the actual component side. If we go down here, there it is, right? So this rig layer that we use, and it's on every component and the rig, is connected to the root transform. Obviously, this root transform is not connected to the rig layer. It's actually part of our component, right? So root transform. Everything is the exact same between all our components and all our meta nodes to a certain degree. So for example, we have component definition, which we'll have a look at in a second. We have the actual component group, we've got type, and so on. The type and the actual class is different. If we have a look at the data, it might look scary. You don't need to know exactly what it's storing right now, because we'll get into that when it comes to serialization. But this is one of the most important aspects to Hive, and that is the data. The data that stores, which is basically a cache of your rig, a description of your rig. This is what we call the definition. Now we'll get into details of what the definition looks like in another video, because that requires, well, it's not pretty to look at. This data is what we use to recover your rig. For example, I can actually pull this data directly from the meta node and reconstruct your rig. That's the way it works. This allows us to go between our build modes in a safe, orderly manner, where even if you delete the entire guide system, it still recovers it because that guide system is serialized into JSON data and stashed into a set of attributes. Those attributes store a specific set of data that allows me to recover what you've made changes to for that component. And there's quite a few attributes here that store different types of data depending on the kind of state you have and depending on the component. Some components don't require most of this, while others do. We also have other things for a component, for example, whether a kind of build state that component is in, like has guide, doesn't even have the skeleton. You also find things like the God node attribute name, which is the actual name of your component. But you also have the component type. That component type allows us to look up against our Hive registry to be able to grab our class, so we can instantiate it for you. And let's leave this video here. And in the next one, we're going to jump straight into Python and start working with the metadata.